we are going to change gears a little bit now and have some fun with hacking in batch mode. So we're going to focus a little bit more on what batch mode operators can do and why we might want to have them even if we aren't really using a column store index. And we're going to look at a different table now. We're going to look at a table named ag.firstNameByYearState. And it looks like I have the table name a little wrong in my comment there, so don't tell anyone I fixed that. We've got an index on this table that is just a normal old row store index. It's on 4 key columns, and it includes 1 column. So we're going to go ahead and create that index on the ag.firstNameByYearState table. Ag.firstNameByYearState is an aggregate table. So it contains, for each year, for each first name ID, the total number of babies born, the name count for babies for a given first name ID, state code, gender, and report year. It does not have 1 row per baby, in other words. So we're going to have a procedure created that is not great code. I'm going to go ahead and create this. It's called popular names. And popular names, I created it purposefully to be kind of bad. So it's a little slow, and I'm proud of that. It takes a parameter called threshold, and it does some running totals for different years. And what it's going to figure out is, if you give me a given threshold, say the threshold that we like to test with is 100,000, what I'm going to do is look at, for a given state, for a given first name ID, state code, and gender, at what point did that name break through that threshold? So in what year did a baby suddenly become that popular? Where if we say 100,000 for that given first name ID, state code, and gender, when did they break through that barrier? Like last year they only had 99,000 babies total who had that name. But as of this year, we have 101,000 babies who have that name. So to figure this out, we've got to do a running total and then look at what was the running total this year versus the prior year. And then we've got some kind of complex stuff in there about the threshold at the end with wheres and ands and stuff, just kind of making this a fun, slow query to play with when it's run for certain values. So our first run, we're going to use that 100,000 baby threshold, and we're off to the races. Even when the data is in memory, this isn't even a very big table, but because of everything it's doing with the running totals, it turns out to be a lot of work even against a small table, because what we're saying is for every first name ID, state code, and gender, we've got to do all of these different running totals and see when they pass this threshold. I am using, in the query, I am using windowing functions. It's not that I've done this the old way. I am doing these partition by, order by windowing functions. And I'm using lag in the next one. But this is a pokey query to run. So we're at 42 seconds. It's still chugging on. And we're going to see if we can get the actual plan. All right, so our query has finished up. Let's check out the execution plan. Well, I've got a warning on the properties, and let's take a look. Click and make sure we can see what the warning is on the properties. SQL Server is saying, hey, I granted this about a meg of memory. It only used about 16K. Now, a meg isn't a huge amount of query workspace memory to give it, but it ended up using just a fraction of that, so we got the warning. Looking at our query execution plan, what happened in here? Well, I keep scrolling to the right. A lot happened in here. We scanned our non-clustered index. So it did use our nice non-clustered row store index on the table, and the scan totally makes sense. I've got to do a running total for each first name ID and then figure out for that first name ID for the state and the gender. I can't just do a seek or anything. I've got to figure out when they broke through this. And we've got multiple window function aggregators. Notice that each of my operators I've clicked on, these are all in row mode. we aren't using batch mode, and we don't have any column store indexes on our table. So SQL Server currently in SQL Server 2016 Service Pack 1 is just going to use row mode for all of these. We have segment operators, we have a window spool operator and a stream aggregate, more segment operators. So we're working through our windowing function, and we've just got so many operators that this has to flow through that do a lot of work. Now we can look at, if I click here just up to this stream aggregate, these are all row mode. So we can, if we want to figure out where we're spending our time, we can see that, by this time in the query, we're at, and this is for it and its children, we're at 75 seconds already. So we can kind of go down and see, if we want to see, okay, at this operator, how much time were we at? We can kind of figure out that was 70,000. Okay, if I go back to the sequence project, at that time I was at about 64 seconds, but we can kind of see it's just building up through these operators because there's a lot of legwork to be done the way that we're doing this query. Well, can we speed this up with batch mode operators? I'm going to create a really weird column store index. I'm putting it just on one column on state code in our table. Our query uses a lot more columns than state code, and I'm creating this column store index as one that just won't be very attractive for our query because our query needs a lot more than state code. We need first name ID, we need gender, we need lots of stuff. But I'm just creating the column store index, and I'm now going to go ahead and run the exact same query with the exact same threshold. And SQL Server sees that a new index has been created on a table, and wow, this query was way faster than a minute. This query took 2.7 seconds. When I look at the execution plan, things are a little bit different. Notice that I didn't have to scroll very far to the right. We have many fewer operators, and we have different operators. We still have a non-clustered index scan. This is of our disk-based row store index. That is not a column store index, right? That's index scan non-clustered, and when I look at the properties, right, this is just our plain old, this is row mode, right? This is our plain old, let's grab the object name down here just to prove it. Let's make that column a little better, right? This is IX first name by state, index first name ID, blah, blah, blah. Right? No cheating here. That is not a column store index. And this is not a column store index either. This is a clustered index seek. SQL Server saw, hey, that column store, that non-clustered column store is on state code. I don't want to use that for this. But if we look at our window aggregate here, we were in row mode for the index scan, but it passed the data into a window aggregate operator, and when we look at the execution mode on it, it is batch execution mode. And in fact, this window aggregate operator is a new batch mode window aggregation operator in 2016. SQL Server wasn't able to use it the first time I ran this query because there was no column store index on the table. I created this sort of super lame column store index on one column, and it decided not to use it, but now it had the option to use the batch mode window aggregate operator. And when we look at the actual time statistics, which are just for it, not for its child, it's pretty speedy at doing its window aggregation, right? So our index scan took about 2.2 seconds to grab all that data from that row store index, but our window aggregate operator's really fast. We've got to do a little work in a compute scaler, which was 29 milliseconds, and then we're going into another window aggregate operator, which is, I don't know what kind of magic they worked in this batch mode window aggregate operator, but man, that's fast. And we end up being able to do all this magic that used to be spread out across all those, segment project and different operators, just in a few operators that are just like magically fast using batch mode. Because this window aggregate operator is the new 2016 magic batch mode operator. And in terms of what operators can use batch mode, with increasing versions of SQL Server, we've had kind of, with different versions, new capabilities. Which capabilities you can use will depend on your SQL Server version, as well as things like your database compatibility mode. So it's worth paying attention to all these little settings in SQL Server. But wow, that made it really fast. Well, even though it chose not to use the Columnstore index, it was able to do it. So what if we did something a little differently? What if we added a hint and we wanted to make sure that it didn't use that non-clustered column store? I showed you that it chose not to, but what if we added a hint to the query and said, I want to make sure that you don't? Well, we may run into something a little different here. I'm going to create a procedure named popular names with a hint, and the only difference in it is that it says ignore the non-clustered column store index. And I'm just going to do an estimated plan here. So this little symbol is sort of like, this is supposed to be like a little thinking bubble with the execution plan. And it'll show me an estimated plan right away without running it. And when I look at my estimated plan, we are back to that 1 minute plus execution with all of the segment operators and the sequence project operator. We are back to the slow operator, or the slow execution plan. We do not have the super cool batch mode operator. Now, Nico, who writes excellent information about Columnstore, he has a post where he points out that this is a change that we got recently. In some cases, right now in 2016, at compat level 130, if you have a Columnstore index on the table and you force SQL Server to not use it by way of a hint, and this might be either an index hint forcing a row store index, or in my case, it was that ignore non-clustered column store, this now disables batch mode. In some cases, if you lower your database compat mode to 120, going back to earlier behavior, you can get the batch mode back even though you're forcing it to not use the column store. But Nico warned in the post, you may miss out on many improvements that you get from compat mode 130, where just many things in column store are made faster. So I would say the lesson to take from this is, if you are using Columnstore, or if you're using any of the hacks I'm going to show you, or if you're just using Columnstore, to keep in mind that index hints may disable batch mode. I would try to work around that and get the performance I want while staying at the highest compat mode, because I get lots of performance improvements for Columnstore with the highest compat mode too. But of course, the final decision is up to you. Just know that index hints at compat mode 130 may disable batch mode on your operators. So I'm going to drop our goofy column store, because you don't want to be creating a column store index on a single column to be getting batch mode. You want to either be creating a real full column store index on all the columns you want it for and really using it, or if you have a case where you just aren't ready to fully use column store yet, and maybe it's because of the insert rates on the table, maybe it has to do with just not being ready to manage column store. Maybe there are reasons that it's just not suitable for your table, but you still want batch mode. There are some clever hacks out there that can get you batch mode without really using column store, and it's way better than a single column store index.